Alright, so today what we'll be doing is we'll be demonstrating how to use the new mag oxide procedure for Graymont. This procedure requires very little amount of our dolo stone. This is a weighed out sample of our dolo stone. It must be at least 0.5 grams, and a good range to shoot for is between 0.5 and 0.55 grams of dolo stone crushed up to legal size. So with our dolo stone, we're going to add it to a beaker like so. Kind of swirl it around, break it up a little bit so there's not one big mass in the middle. And then we're going to measure out 10 milliliters of 50% hydrochloric acid. It's also labeled with the red and the number 1. So we'll go ahead and measure this out right now.
So that red that you pointed out, it's kind of a color code, isn't it?
Yep.
Based on the procedure that's on the wall.
Absolutely.
So this kind of helps you out. You can match those colors to the various chemicals here that are used for the test.
Yep. Before we add our acid to our beaker, we're going to turn on the fume hood here. It's very important that whenever you're using the hot plate, that the fume hood is always on, and when you're also handling your ammonia buffer, which you'll see here in a little bit.
Okay.
So all you do is you just turn it on, and then you turn it all the way up to F4. That's the strongest setting there is. That way you won't be breathing in any harmful fumes.
Okay.
So now we'll add our acid to our beaker, holding it away from us, don't breathe any of the vapors. Swirl it around a little bit, and now we'll set it on the hot plate. We're going to turn up the hot plate to a very, very high setting, just so the acid can evaporate off rather quickly.
Okay, so that hot plate, that's a dual plate, right?
Yep.
It also has a
acts
mixer?
as a stir plate as well.
Okay.
And you can heat and stir at the same time. So what we'll be going for here is, once everything is all dissolved, after the acid is all dissolved, you're going to see a yellow-white precipitate on the bottom. And that's when you know you have reached completion of heating.
How long does that typically take to...
On a high setting like what we have now, it should take no more than about 5 to 7 minutes.
Okay.
So during this time, we'll come over here. During this time, a big thing that you can do is you can calibrate your bottle top dispensers. And in order to do that, you crank the neck 90 degrees to the right to start out with. Adjust the clip up to a range less than about 4 mils. And you're just going to pump it a couple of times. And what you're looking for here is no air bubbles in this window.
Right down there.
Yep. So as you can see, there are no major air bubbles right now. That means your dispenser is calibrated and ready to go.
And it's important to put it to the side there. That way, you know, no liquid's going to be pumping out of it.
Not out the spout, no. It's
right.
just going to be dispensed back in the bottle. And then you just turn it another 90 degrees to the right, clockwise, into the dispense position, and then adjust it down back to where it was preset before. Let's do this again real quick with the ammonia. No air bubbles, good to go.
Now,
Bam.
can you just show us on this dispenser where the little tab is?
Sure. So the graduation marks on our bottle top dispenser go from 1 to 10 milliliters. This arrow right here, this denotes where you are at for a volume that you're going to be dispensing. And all you do to change that is just move this clip either up or down to the desired amount. So for the ammonia here, we had it set at about 5 milliliters to the liter.
Okay.
So it's really easy to do.
Great.
And then another tip, or another thing to do as you're killing time, we can fill up our burette. And there's a little cheat code right here. On your stopper, one end of the stopper is colored black. So to fill your burette, you're going to point your black end upwards, and you're going to squeeze your EDTA bottle. filling the burette with our EDTA test solution. Now this is a self-zeroing burette, so what that means is you can just keep squeezing and squeezing and squeezing until you see it, the solution start to overflow in the overflow chamber. And once you see that, you can just close your stopper and you know you have a perfectly calibrated burette every time.
Right there it started to overflow, and it overflows back into this other bottle.
Yep. And then just another quick thing to do before we get started.
Well, you can see it, it's really boiling now, and it's turning white.
Yep. So it's almost done.
It's getting there.
So then another thing before we get started here, we're just going to calibrate the tip of our burette.
Okay, Brett, could you demonstrate that again?
Yeah, so along with filling the burette, you should calibrate the tip by just dispensing some of your EDTA out to allow any air bubbles in here to go away.
Okay.
And then with the solution that you lost, just refill your burette. Well, sometimes the hose will kink on you, so just make sure the hose isn't kinked. And now our burette's ready to go. And by doing all that, it looks like all of our acid has dissolved off into a nice white-yellow residue. The next one we're going to do is we're going to add 25 milliliters of this 10% hydrochloric acid solution with the yellow number 2 on here. And this will go right into our beaker on the hot plate.
And these chemicals are stored in the back room in the chemical cabinet.
Yep. Or sometimes they will be in here, depending on how long ago the last test was done. So you add your 25 mils of your acid. You'll turn off your hot plate so there's no more heat coming on. And you'll just dump it right on right away. You'll see some gas evolution, that's normal. And then alongside with 25 mils of acid, you're going to counter that with 75 milliliters of distilled water, which we'll add it by using this cap that was specially made. So tip here, we'll measure out our 75 mils by just filling up the beaker with water until we get to the 100 milliliter graduation mark on the beaker. Like so. Maybe you want to zoom in on that. And then from there you'll just let it sit on the hot plate for about 2 to 3 minutes just to get a little extra heat and to allow the water and the acid to mix together to form a nice solution for us.
So basically that acid is there to kind of dissolve the residue.
Yeah.
Yep.
So we're just getting our hot mat set up here before we pull it off. Just note when you're using these acid solutions, these are very strong. They will burn you if you don't wear nitrile gloves, so make sure you're wearing gloves and eye protection at all times. And also, when you're measuring out 10 mils and your 25 mils, they don't have to be exactly 25 and exactly 10. So if you overshoot a little bit, like say I overshot to 27 milliliters with our 10%, that's just fine. You want to get at least 25 milliliters of acid in there, or at least 10 mils of acid in there as well. It's just used to break down the product. And again, this will be the biggest amount of downtime that you'll have from doing this experiment. You're just waiting for it to heat a little longer. So during this time, if there's still some setup stuff that you need to do, feel free to go right ahead and do it. So you can do 2 titrations back to back and then input your data into numbers. And all I did here was I put our pH probe into a beaker of distilled water just so we can get it ready to go when we start to do the titrations, because we need to reach desired pH levels in order for these to work. So just let it sit in water. Sometimes you'll see a little battery light flashing, that just means the batteries are going bad. And right there you'll see that the pH pen is reading at about 8.36, 8.35, which is pretty standard for a drinking water. It's a little high, but it's not going to be a perfect 7. So now that this has been sitting on the hot plate for about 3-4 minutes, slide our mat over under the fume hood because there's still a little bit of gas coming off. And we'll take our 250 milliliter volumetric flask and we're just going to dump this solution into the flask. Now be careful, the contents of the flask may be hot. Another little tip, that is for filling. Another trick to pouring your solution into your flask, you can use this little funnel. It might also help with getting all the solution into the flask and not spilling everywhere. So now that our solution's in the flask, we'll leave our beaker here to cool. Then we're going to add just distilled water up to the silver line on the volumetric flasks. And all volumetric flasks will have the silver line.
Okay.
So again, you can use your filter, or your funnel I should say. And you'll fill it up to just about below the neck. And then you'll top it off with the squirt bottle of distilled water.
Up to the white line.
Yep, the white silver line. Like so. So from here, we'll stopper the flask. And we're going to invert it probably 3 or 4 times so everything can get mixed together. And there you go, your test solution is made. So from here, we'll go on to doing the titrations. When doing the titrations, you will make the solutions in beakers. Set up 2 beakers. We'll do 1 titration at a time for this purpose. So the first titration we'll do is our CaO titration. We're just going to follow the procedure that's up on the wall here. CaO's first, then MgO second. You can do it whichever way you want. You can also do both at the same time to save time. For our purposes, we'll do 1 at a time to walk you through. So you'll add 20 mils of your lime acid solution. A beaker here, and then you're going to add 130 milliliters of distilled water, or a little fast tip for you, take your distilled water jug and just fill it up to the 150 milliliter graduation line, like so. From here we're going to put our pH pen in, and you'll see the pH of the solution drop to around 1. That's normal, that's what we like to see. We know the solution's acidic. Now to reach our desired pH in order to make the titration work, we're going to add potassium hydroxide, blue number 3, into our beaker here. We're going to be shooting for a pH of around 12. So a little important tip here. The lifetime of these solutions affects how strong they are. So like some of these solutions will lose their potency or their effectiveness if it's been a while since they've been made last. So you'll find yourself adding more and more base every time. So it's important to always shoot for 12 on the pH pen or 10 on the pH pen for the MgO titration. Don't go by adding a certain amount, always go by what the pen tells you. So we'll add our potassium hydroxide into our beaker in 5 milliliter increments. Just pull up and dispense. So careful little gets on the pen. Just swirl it around so it gets mixed into the solution. And it looks like we'll have to add another 5 milliliters to get it up to 12. Perfect.
Yep, you're 12.13.
Yep, and that is fine. You don't really want to get too far above 12, like into the 12.5 range. It's a little too basic. Try to shoot for around 12. So now that we're at the right pH, we'll put the pen back in water just so the bulb on the bottom of the pen can stay moist so it doesn't get destroyed. And now we'll add 10 milliliters of 30% triethanolamine, purple number 4, to our beaker. Just pull up, dispense, and good to go. Give it a little swirl. Grab a stir bar, plop it in, put it on the plate, and let it stir. We're going to let it stir for about a minute or so. During this time, we're going to measure out our indicator amount to put into our solution. So we'll go over to the scale. So for the CaO titration, you use hydroxynaphtol blue indicator. It's a long name, but just remember that it'll be labeled for CaO on here. What you'll see is this is about the same color as your nitrile glove. It's a little purple color. So what we do is so we'll take our whey paper, and now I'll add 1 scoop of our hydroxynaphtol blue indicator onto our whey paper.
So that's a special little spoon, so to speak, that
helps control the amount you put in. It's usually about 1 scoop, maybe 1.5. Depends on how much you get in there. Basically what you're looking for is you want to get anything. You want to get it between 0.15 and 0.2 grams of indicator. You don't need to record this value at all. So take our indicator over, put it into our beaker, allow it to mix. Really just letting all the powder get it mixed together. So see that nice pink color. We'll bring it over to the red. So put it on, turn on the stir plate. And then we'll begin our titration. Black end down to dispense. And now you let it run until you get down to about 35 milliliters. That's when you'll start to see the color change take place.
And the color change is going to be a bluish.
Yep,
change.
a bluish purple color. You see it's starting to change color a little bit here, so we'll knock it back a little. It's going to be that first color that you see when it stays like the purple endpoint for about 30 seconds or so. So it looks like we're just there. Let's spin for a little bit just to see if we...
So at the end there, you were just going drop by drop to...
Yep. Add a little more. There's your endpoint.
Yeah, it's like it is like a bluish purple.
And then from this, you'll record your titration value, which looks to be about 35.2 milliliters. So write that down. When this is done, everything can go right down the drain, reagents wise. Side. Feel free to rinse it with vinegar if you'd like. And now we'll move on to doing the MgO test, which is going to be very similar to the CaO, except it's going to take a couple different steps. Still start out with 20 mils of our lime acid solution. We'll go into a clean beaker. This time we will add 80 mils of water, or fill it up to the 100 milliliter graduation mark on the beaker. Like so. Grab our pH pen. Sometimes it turns off automatically if it's not being used, that's fine. Pop it back in. You'll see it's down at about 1. And now this time we're going to add ammonia buffer to MgO with the green number 5 on it. This buffer is a little bit fumey, so please do it under the fume hood. Fumes are not toxic, they're just very unpleasant to smell. For this titration, you're going to want to shoot for at least 9.65 for our pH. The overall goal is 10. So we'll try to shoot for 9.65 by adding 5 milliliter increments of ammonia buffer. We're almost there. We'll add one more shot for good luck. You can get a little bit. You can get a little whiff if you're standing right under it.
9.7.
Yep. So that's good. And we'll close the ammonia right away because we don't want to be breathing in any of that stuff. It's not very pleasant.
So to close it, you turn it up.
Up 180 degrees.
Yeah, and when you're not using them, they should look like that.
Yep.
Turned up.
So to our solution, we're going to add 30% triethanolamine, purple number 4, again, 10 milliliters. A little rough swirl by hand. Stir bar, stir plate. Stir for about the same amount of time. While it's stirring, we'll add our indicator. For the MgO, we'll use this Calmagite solution. It says 4 MgO on there. You can just add it right to the beaker whenever you're ready. Add about 2 to 3 drops. That's all it'll take. If you want, you can add a couple more if you want to see more of a definitive color change, but 3 drops will be defined enough.
Well, it's like a pinkish
Yeah.
kind of color right now.
Both indicators start off as kind of like a pink, like in a phenolphthalein solution. So just let it stir for just a little bit so the indicator can get mixed in. Before we do anything though, we need to refill our burette. Black end up dispense.
There's the black end on that knob.
good. And now we can dispense into our solution. You'll start to see a color change roughly around 65 milliliters, so you can let this one open up and dispense out until it reaches about 60 to 65 milliliters when you can slow it down. It's important to note that whenever you do this titration, you're not going to get the same numbers every time just because of the variability in our product, but they should all be within the ballpark of each other. We do have a little guide on the wall here that shows you what a good titration range is that would yield good results when put into Winlands and the LOI file.
So CaO should generally be 35 to 45 mils, MgO around 65 to 85 mils.
Yep.
So now we're getting close. That's 60.
Starting to see a little bit of a color change right now, not much. Once this starts to really change color, it will turn rather quickly. Should be going here at any minute.
Yep, starting to go.
Probably needs one more little squirt. And that looks pretty good.
Yeah, it's a bluish color change, kind of a purple blue again.
Yep. Kind of similar.
And you just got to
CaO.
get used to that color change. Like Brett said, you know, you can put one or two more drops in just to confirm that you're there.
And then you'll record your titration value down on just a side sheet of paper, which looks to be about 75.6 milliliters right now. And if these clasps get in the way, just feel free to rotate it to the side.
Okay. So there's your level.
And now from here, we'll just turn everything off. Everything goes down the drain. Rinse out your equipment with water. If you'd like, you can rinse it with vinegar as well. Whatever you are used to doing with typical glassware cleaning, that's fine. You'll get a little bit of the ammonia fumes when you dump it down the drain. So with your ammonia beaker, try to aim right for the drain directly, opposed to swirling it around and really getting a lot of smell coming out of here.
It's good advice. Can you show them where most of the glassware is stored?
Yeah. All your glassware for this titration can be found in these two cabinets right here.
Yeah.
The majority of it's taken out right now, but you can see we have a lot of excess Erlenmeyer flasks, volumetric flasks, beakers, and whatnot. There's more glassware. It's stored elsewhere within the lab and out back.
So if things get broken, you know, we have spare parts.
Oh,
There's,
There's some extra
yeah, that's a good point. You got more
glassware down
more
here.
glassware here. And that special stopper that's on top of here, is that usually
It's usually right in this top,
stored in this drawer?
somewhere up here.
Along with this spoon, right?
This spoon and the indicators usually sit right down in this corner.
Okay.
So they normally sit on this piece of weight paper.
So with that said, this half of the lab is, most of it's dedicated to this mag oxide test.
Yep. And when you're done doing the titrations, you have a little bit of EDTA left. Turn the stopper up in the dispense position, and you'll see it start to drain down back into our bottle here. That way we can just recycle and save our EDTA, so you don't have to make it as much.
So it's better to drain that out when you're not using it?
Exactly.
Okay.
If you left it in there, some of the solution might start to crystallize, and then you get some salt buildup in there, and then it'll just be one big mess.
Can you demonstrate, when you're done here, demonstrate entering the data in the computer?
Sure. So we can go back to the computer.
There's a special tab. This is all contained on our normal LOI file.
You'll enter your data here in this Mag Oxide tab.
Okay.
Click on that. And what you'll do is you'll put in the date. What's the date today?
The 9th.
Normally you would put in your where the sample is from, which Winnipeg Railcar. For now we'll just put training. In this column you'll put down your mass of dolo used. The next column you'll put your CaO titration value. You're going to jump a couple columns over to the start of the MgO titration column. You'll put in your value there. And then you'll scroll over here to your percent MgO and percent CaO values. And these two values right here is what you would shoot for. Or these, I shouldn't say shoot for, these are what you would give out to either Kelly or whoever is asking for the...
Yeah, those are the numbers that the customer would be interested in. So it looks like it's about 43% mag oxide and just over 51% CaO.
This value is a little high, but for now, that'll do. Normally you'll see values around 36 to 41.
Yeah.
Some get a little lower, some go a little higher. Same with CaO, you'll see it in the mid-50s.
But you know, there is going to be natural variation.
Yep.
And the more testing we do, the better we'll be able to determine what the variation or limits that you should be between.
Yep. And with that, that completes the mag oxide test.
All right, thank you very much, Brett.